Distance and displacement are key concepts in AP Physics 1. We must be able to differentiate between the two concepts for different problem types and scenarios. To begin, we must first realize the concept of distance. This is the measurement of the total distance traveled. For instance, if we were to walk down the street and walk back, it's intuitive that the distance will be the length of the walk both down the street and then back up. Such can be seen in this mall diagram. If we have a person who is walking from one side of the mall to the other, then coming back to the original side of the mall, we can calculate their distance based on the distance to one side and then the distance back. In this example, we can clearly see that the distance to the west side of the mall is 1 mile, and the distance to the east side is also 1 mile. Easy enough, we can plug these values into the formula for distance, the product of distances, and add 1 mile to 1 mile to get a total distance of 2 miles traveled. While distance is intuitive in essence, it's important to realize the background information behind displacement. We can apply it to the mall walk example. We know that the walker had to go 1 mile in the eastward direction, then 1 mile back in the westward direction, for a total distance of 2 miles. But our displacement isn't 2 miles. Why is that? Because displacement measures the distance between your final position and your initial position. In this example, since we're going the same amount of distance in one direction and the same distance back, our displacement can be measured as 1 mile minus 1 mile, which is 0 miles, which intuitively makes sense because our any position and our final position are the exact same, which means our displacement won't exist. It's crucial to recognize the key differences between distance and displacement, because while similar, they hold completely different roles in problem-solving methods. We must recognize how our everyday actions can be measured in both distance and displacement, and why it's important to use one over the other in certain scenarios. For example, if we wanted to accurately describe the journey of a race car driver who's partaking in a long race, we must realize that their final position at the flag on the racetrack and their initial position, also at the flag of the racetrack, will be the same position, which resembles the displacement of 0 miles. However, we can't describe this journey as having a displacement of 0 miles, because we must recognize the distance traveled to show the actual trip. This is the crucial concept towards realizing which type of measurement we must use in any given scenario to display the actual logistics of a trip on a grand scale. That's it for distance and displacement.